So if we want to, there are some more advanced ways to handle this. And you can see here, this code is going to produce an error because X doesn't exist, right? So we've got a try statement up on top, and then we print the value of X. X doesn't exist, so that's going to produce an error. Now we've got two except statements here. Except name error and a generic except. What this does is it says when this happens and it generates an error, it will go through each except and it'll say, is this the specific error that we're having? If it is, then it does this. If not, it will just keep going to the next one and the next one. You can have all kinds of specific errors defined. And if you just use a generic except, you can just say generic problem here. Let's play with this code a little bit. So let's get rid of my random characters that got inserted here. Okay. So now you can see here that X is underlined in red because it's telling us already it's going to generate an error. So if I don't have these try statements, let's just look at this without this. Let's not delete it though. There we go. So if I just say print X, that's going to generate that error for me. So if I run that, okay, there's my error that's not handled. All I did is just print X, which doesn't exist, and it says this, name error, name X is not defined. It's telling me what the error is. It also tells me where the error is on line 1, so that's all useful information. But this, notice this here is the type of error that I got. So if I want to catch specific types of errors, I can do that. Let's say X is defined. X equals 1. Okay, that works because I've defined X. But let's say I want to say this. That's going to generate an error also, right? So I run that. Now look. So it tells me what I do. There is the error type. So I can put an exception for that error as well. So let's do this code. So let's uncomment that. And now, when I run this code, you'll see that it prints X isn't defined because I've got a name error there. X isn't defined. The program's not crashing. You'll notice the process finished with exit code 0, meaning there are no unhandled errors. It didn't crash, it just caught the error and handled it. So now if I want to, let's say I can make X equal to 1 there. Now, of course, that will work. And if I say this one, now remember that generated a type error. So instead of hitting this exception, because that's specific to name error, it's jumping down to the generic something went wrong and printing that instead. So it gives you a lot of control, and I can have more than one named except here. And all you have to do is cause that error to happen, and then you can see what the name of it is. Or you can look up the different can't mix types. Just like that. So now when I run this, it gives me that error, the type error. So if this is not defined, I get the name error. If that is defined, then I get a type error. So that is easier to ask for forgiveness than permission. And you can see it gives you a lot of control over what happens in the program next. But if you're doing that with user input, then it becomes pretty easy to handle that error depending on what the user provides you as input. Now, here's an interesting thing that you can do. You can also add else with try. So I can say try, except, and else. Else will work only if nothing went wrong. So if this try works, it will do this. If there's an exception, it will skip else. Else is a little weird because if you think about it, I could just take this, nothing was wrong, and put it up here right after this print statement, and it would do the same exact thing, right? Because if I had an error here, it's going to skip that line anyway. But there may be a case where you use else in that way. Another thing you can do is finally. Okay, finally is part of the try except branch, and finally gets printed if there's an error or if there's not an error. So both. So finally gets printed no matter what. Now, if you're paying attention, you might be asking yourself, why do we need this? Can't we just put a line of code right after the try? Yes, you could. In most cases. There might be a case for this. And one of the cases for this would be if inside here, inside the try, you open a file for reading or writing. If you open a file inside try and then there's an error, that file will stay open. And if the program exits with that file open, it could cause corruption or errors. So what you might use finally for is the file gets open here, make sure it gets closed, no matter what. So that's a case for using finally. And in just the next couple of weeks, we're going to be reading to and writing from files. The exciting part about that is that what that allows us to do is save information between the times that we run programs. So in other words, like you quit your ATM program, it saves your balances, right? If you have a database of employees, it'll save that for you. So we can do a lot more once we start reading and writing files. But that's a case where you might want to consider using finally.